All right, guys, section 6. This is actually going to be our last one. I think I might have told you last week we're going to do section 7. We're going to pass on that. So this is going to be our last one. We'll review on Wednesday, and the test is going to be this Friday. So last class we said we're going to build up to solving equations, and that's what our goal was, okay? So today we're going to be solving exponential and logarithmic equations. Now, this key concept box, 4 main ideas of how to solve logs, okay? And I will show you as we go today some common mistakes people will make, okay? First thing, we've seen, I guess, half of these already, but if I have log base b of b, well, those will cancel and I'm just left with x. All right, so if we're taking log base b of b, and these are the exact same number, well, then they're going to be canceled, and I'm just left with whatever my exponent is. Okay, same idea here, that if I have b to the log b, and again, those are the exact same, well, then those will cancel, and I'm just left with x. Okay, so those two properties on the left are essentially the same two properties on the right, okay? Except it's just, yeah, we're using natural log and e. So natural log and e, okay, those will cancel, and I'm just left with x, because again, natural log is base e, so this is essentially natural log of base e of e, which is very similar to there. We just don't write this e down there, okay? And then here, if we have e to the natural log, those will cancel, and I'm just left with x. So when solving these exponential and logarithmic equations, we're going to be using these properties. Okay? So in this first example, guys, the number one concern, or the number one issue in solving these equations is people want to do this. Divide both sides by 5. Because we've been doing that for, gosh, since 6th grade, 7th grade. Okay? But this is not 5 times x, this is 5 to the x. Okay, so we cannot divide, all right? But to undo this and to get my exponent, if I can slide this over, what we need to do is log base 5 of both sides. Well, why? Because of this right here. I know that if I have log 5 of 5, what's going to happen on the left? They're going to go away, and I'm just left with x. But we need to do it on the right as well, so it's kind of hard when you don't have a lot of room, so you need to log base 5 of 3. So if I rewrite this, guys, let me rewrite this so it's not so confusing, but what I'm doing is I'm logging base 5 of both sides. So on the left hand side, those will cancel, and I'm just left with x. Now, on the right-hand side, I have log base 5 of 3. How am I going to evaluate that? How do I do this? Log base 5 of 3. That means 5 to what power gets you 3? It's going to be some weird, ugly number. How do I evaluate that? Talked about this last week. It's called the change of base formula. We need to do log 3 divided by log 10. Excuse me, not 10, log 5. That's called the change of base formula. You want to evaluate a logarithm that we do not know, that's something that we can't do in our head, we'll do the change of base formula. So in our calculator, do log 10, enter, divide by log 5. Did I say log 10 again? Yep. Log 3, enter, divide by log 5. Well, yeah, it's log base 10, but if you think about this, 5 to what power is 3? It's going to be less than 1, right? Yeah. 5 to the first power is 5, so what do we get there? 6826. 0.6286. Something. 0.8. After that, I'll just leave it like that. No. Nope, 82. Okay. 62.
Like the 8 and 2 need to swap.
Oh, 82.
No. 0.6826.
Give me 4 decimals, Autumn. Point what?
6826.
Thank you. Now we can check ourselves, guys. My calculator isn't working here again. We could check ourselves and take 5 to this power, and again, I'd hit 5 to the second answer to the exact exponent, and we should get 3 there. Okay, so we can plug that in and check ourselves as well. Questions there? And that's our answer. 5 to that power gives us 3. All right, now over here, we need to get rid of the 1 first, so I'm going to minus 1 on both sides. So I'm going to get 3 to the x minus 2 power equals 3. Guys, when I write these, I usually, excuse me, will leave a little space like this because I know I'm going to be logging both sides. So it just helps when I do that to both sides, I've got some room. So now, to get rid of the 3 to the power, or I like to say just have our exponents, we're going to log base 3 of both sides. So on the left side, those will cancel, and I get x minus 2. And on the right, what's log base 3 of 3? 3 to what power gets you 3? And the answer is 1. Okay. Up here, I said, hey, you're just left with whatever our exponent is, which that's the case because what's my exponent here? Maybe I shouldn't put a big 0 there. My exponent here is 1, right? So I'm just left with that exponent. And now I can add 3 to both sides. Add 2 to both sides, thank you. And x is going to equal 3. Now, if we plug that back in, just to check ourselves, 3 minus 2 is 1, right? So 3 to the first power is 1 plus, excuse me, 3 to the first power is 3 plus 1, that gets you 4, and that works. Any questions on those first two? Okay. Again, now we've got e, but don't worry. To get rid of e to the power, we're going to be using natural log instead of regular log. So I need to add 7 first. I get 4 times e to the negative 0.3 to x, and that's going to equal 20. And then I need to divide both sides by 4 before I natural log both sides. Let's get rid of the 4 first. So I have e to the negative 0.3x equals 5. And again, to get rid of e, well, we're going to be using natural log. Natural log both sides. So the e and the natural log will go away. And on the left side, then I have negative 0.3x equals whatever natural log of 5 is. Okay, so do that in our calculator. Round that to anywhere from 3 to 5 decimal places is good. So do natural log of 5, please. $1.609. That's fine. And then I need to solve for x here. How do I get rid of the negative 0.3? Yep, we're going to divide by negative 0.3 on both sides. So 1.609. If you want to be as most accurate as possible, don't use the rounded version of this answer. Use the answer that you have stored in your calculator and divide that by negative 0.3. Negative 5.365. Questions there? Okay. Now, this is a little different. Nothing to get rid of on both sides first. So we could think about logging both sides. Now, if I'm going to rewrite this out so I can write it a little bit nicer. But if I don't write this down, just watch. If I log base 3 on both sides, It doesn't necessarily cancel, though, does it? Because these cancel because they're the same, but these necessarily don't because they're not the same. Okay, so what we'd like to do is rewrite 9 in terms of 3 to an exponent. Isn't 9 3 squared? So I can rewrite 9 to be 3 squared. Maybe you don't want those exponents to be written like that. Because 9 is 3 squared, so let's just change it to 3 squared. So it's like 3 to the 2 times 3x plus 3 power. Okay, so the 2, all this right here, is an exponent. And now I have the same base, I guess, if you will. So log base 3 both sides. So now those go away, and those go away, and I'm left with my exponents. So on the left, I'm left with 2x minus 1, and on the right, I have 2 times 3x plus 3. And now we're just solving this like we've always done it. I can distribute on the right. 2x minus 1 equals 6x plus 6. Add 1 to both sides. 2x equals 6x plus 7 minus 6x on both sides. And I get negative 4x equals 7. Divide both sides by negative 4. And x is going to equal negative 7/4. You can call that negative 1.75 if you want. I'm just going to call it negative 7/4. Questions there? Okay. The next, again, we don't have, I guess, the same base of our exponents. So let's think about how to rewrite this. How do I get 1 over 10? Would that be a negative exponent? Would you guys agree with me that to get 1/10, that's like 10 to the negative first power? Would you agree there? So this is the same thing as this. 1 over 10 is the same thing as 10 to the negative first power. And so then I can put my exponent right there. Now, 100 is like 10 to what power? 10 squared, right? So I've just kind of, I haven't changed the value of anything. I've just changed the form that they're in. So instead of 100, I'm calling it 10 squared. Instead of 1 over 10, it's just 10 to the negative first power. And now they've got the same base, so now I can log base 10. And when you log base 10, guys, remember, we don't put the 10 there, it's just log. Okay, so we're going to log both sides, and those will cancel. And those will cancel. And here I'm going to get 2x equals negative 1 to the x minus 3 power. Or, excuse me, negative 1 times x minus 3. I can distribute my negative 1. I'll get 2x equals negative x plus 3. I can add an x to both sides. 3x equals 3. Divide both sides by 3, and x is going to equal 1. Questions there? Do this next one on your own. Go. Okay, so 81 is going to be 9 squared, and 1 over 9 is going to be 9 to the negative first power. So here I'm going to get negative 1 times x plus 3 equals 9 to the 2x. Very similar to the last one. Excuse me, this is just going to be 2x. Distribute here and get negative x minus 3 equals 2x. I can add x on both sides. Negative 3 is going to equal 3x. And x equals, you guys get negative 1 there? Yep. Questions there? Okay. Now, top of the next page, it says example 2, we're going to be solving log equations. I'm going to go over the second one first, okay? Second one first. So I have log base 2 of 5x minus 17 equals 3. So to get rid of log base 2, okay, we're going to say, well, we're going to exponential both sides, or exponentiate both sides. So we know, if I go back up to the top of the front page, if I do b to the log b, they will cancel. So to get rid of log base 2, we are going to exponential both sides. Exponentiate both sides. That just means, hey, we're taking 2 to that power. Remember, anything you do to one side of the equation, you can do to the other. So now when I 2 to the log base 2, those will cancel. So on the left side, I'm just left with 5x minus 17. And on the right, what's 2 to the third power? 8. Guys, a huge mistake, a huge area of concern is people calling that 6. Because we're just sloppy, we just think 2 times 3, bang, 6, and it's, yeah, and the next, everything we do after this doesn't matter, it's wrong. Okay, it's 2 to the third power, which is 8. And now I can add 17 on both sides. 5x is going to equal, what's that give me, 25? 25, divide both sides by 5, and here I'm going to get x is going to equal 5. Okay, you guys got your calculators? Okay, just type in log, I'm just making this up here, type in log of negative 2.
Doesn't work.
What?
Doesn't work.
Doesn't work.
Non-real answer.
Okay, so we cannot take the log of a negative number. It just doesn't work. And if you think about it, if I just do log base 2 of negative 8, 2 to what power gets you negative 8?
1/3.
Negative 1/3, that's going to be like the cube root of 8. Okay? You just can't do it. Okay? So we can't do it. So what we need to do here is just plug our value back in. Plug this value back in and make sure we're not taking the log of a negative number. Okay, so when I plug that back in, I get 5 times 5, which is 25. 25 minus 17 is 8. Positive number, that's okay. If we were to get a negative number, we're going to take the log of a negative number, well then that would be an extraneous solution. It can't work. Okay, so just plug that back in and to make sure we're not taking the log of a negative number. Okay, a mistake that a lot of students will make is to say, oh, well this is positive, so it has to work. Or if this was negative 5, okay, it doesn't matter what this number is, it matters what this is. Okay? Okay, now, I've got natural log, so to get rid of natural log, we're going to use e. So I'm going to exponentiate both sides using e. Now those will cancel, and I have 4x minus 7. And x plus 5. Okay, I'm going to minus x on both sides and get 3x minus 7 equals 5. Add 7 on both sides. 3x is going to equal 12. Divide both sides by 3. And x equals 4. Again, let's just go back up. Here's going to be 16 minus 7. That's going to give me a positive number. I like that. 4 plus 5. That's going to give me a positive number as well. I like 4. Questions there? Okay. Third one, well, I've got log base 3 of on both sides. Well, to get rid of my logs, I'm going to exponential both sides. Exponentiate. Those will go away, and I'm left with 2x plus 8 equals 6x minus 12. So if I minus 2x on both sides, and from here, guys, we're solving like normal. Nothing's new there. 8 is going to equal 4x plus, minus 12. I'm going to add 12 on both sides. So 4x equals 20, and x is going to equal 5. Again, just to plug those back in, I'm going to get 18 on the left, which is fine. And here I'm going to get 30 minus 12, which is 18. Again, that's a way we can check ourselves too. I'm going to get log base 3 of 18, log base 3 of 18. Those are going to be equal to each other. Good to go there. Okay, next three kind of involve these properties that we learned last class. Okay, so I've got log of 2x plus log of x minus 5 equals 2. So we know that if we're adding two logs, that's the same as doing what with one log? Multiplying. So let's condense this first. So I'll say log of 2x times x minus 5 equals 2. So before we do anything, we want to condense those two logs. All right, now, how do I get rid of log? Exponentiate. What's my base, though? 10. So exponential both sides. And that will cancel there. And so then I'm going to have 2x times x minus 5 equal 10 squared is 100. Where do I go from here, though? Yeah, let's distribute. So I'm going to get 2x times x. That's going to give me 2x squared. 2x times negative 5 is going to give me negative 10x. And then this is going to get me equals 100. I heard a couple things. None of them I didn't really like. I've got x and I got x squared, right? When I have x squares and x's, I need to get everything equal to 0. So I'm going to minus 100 to get everything on both sides. So 2x squared minus 10x minus 100 equals 0. And now we want to try to marf. Okay? Is there a GCF there? There's a 2, right, Tyler? And there are 2 and everything? So I can take a 2 out and say x squared minus 5x. If I take a 2 out of that, what am I left with? 50. So now I can mini-marf. What are factors of negative 50 that add up to negative 10, or excuse me, negative 5? What? 5 and 10? Oh, negative 10, positive 5. So if I factor this, I still have my 2 hanging around, but this is going to be x minus 10 and x plus 5. So I need to set each of these equal to 0. So x is going to equal positive 10 and x is going to equal negative 5. Okay, now if I go ahead and plug these back in, I plug 10 in here. Log of 2 times 10, that's 20. Log 20, that's positive, that's fine. 10 minus 5, log 5, that'll be fine. But negative 5 here doesn't quite work, because log of 2 times negative 5, that's going to give me a negative, isn't it, guys? And negative 5 minus 5, that's going to give me a negative. So we need to omit negative 10, excuse me, negative 5, that's extraneous, and we're only concerned with 10. Okay. Looks like we need to change this one, guys. I need this to be a 4. I must have messed up there. They had different bases, so we couldn't do anything there. But now that they have the same base, again, adding 2 logs is like multiplying 1 log. So I can say log base 4 of x plus 12 times x is going to equal 3. Well, to get rid of our log, we're going to exponentiate both sides, where those are going to go away. I'm going to rewrite this to put the x first. So I have x times x plus 12 equals 4 cubed, 64. Okay, so now I'm going to distribute on the left, so I'm going to get x squared plus 12x, and I'm going to minus the 64 over in one step, so minus 64 there, and that's going to equal 0. So now I can mini-mark what are factors of negative 64 that add up to 12. Negative 64 that add up to 12. 16 and 4. Which one's got to be negative? The 4. So I like positive 16 and negative 4. So I can have x plus 16 and x minus 4. And then when I set both of these equal to 0, I'm going to get x equals negative 16 and x equals positive 4. So if I were to plug those back in, negative 16 plus 12, that'll give me a negative. I don't like it. Negative 16 is extraneous. If I check 4, that's okay. That'll give me 16, and that's going to give me 4. I like that. That's fine. Questions there? Okay. Do the last one on your own. Go. All right, guys, so log of 5x times x minus 1 equals 2. To get rid of log base 10, there's a 10 there. We're going to exponential both sides. I'm going to get 5x times x minus 1 equals 100. Now if I distribute 5x minus 5x squared minus 5x minus 100 equals 0. I can take a GCF out of 5, so that's going to leave me with x squared minus x minus 20 equals 0. Mini-mark this, factors of negative 20 that add up to negative 1, that would be x plus 4 and minus 5, is that right? And then x is going to equal negative 4 here, and x is going to equal positive 5. Now when I plug those back in, the negative 4 shouldn't work, guys. Don't get in the habit of always just crossing out the negative one. It's kind of worked that way, but again, always go back and check to see the value that that we're taking the log of. Okay. I don't know if you've got room at the bottom or not here. I'm going to talk about an idea. Let's say that we put $1,000. Actually, no, I'll make this $1,300. Okay, we put $1,300 into a savings account. Okay, and we're going to put it in there for, let's say, yeah, we don't know. But I don't know how long I'm going to put it in there, but I know that when I'm done, I want to, let's just say, I want to double my money. Okay? So I'm going to put $1,300 into a savings account, and I want to know how long is it going to take me to double my money. So in the end, I want to have $2,600. Okay? And for this situation, let's pretend our interest rate is, let's just call it 3%. And this is going to compound quarterly. So compound quarterly. How long will it take to get to $2,600? Well, what's our compound formula? Compound interest formula. The amount equals our principal times 1 plus my rate over n, which is the number of times I compound, and that's going to be to the n t power. Okay, so what do we solve? What do we need to know? The time, right? We want to know how long do I have to let my money sit there for it to double. So let's plug everything in. My principal is what I start with, 1,300. What's my A? 26, right? That's what I want in my account. 1 plus my rate is 3%, so that's going to be 0.03. It's quarterly, so that's going to be 4 times. And we're going to raise this to the 4t. Are there any questions about how we set that up? We used our compound interest formula, plugged in all the information that we were given. Now, let's find t. What do I need to do to solve for t first? Okay, let's get rid of the 1,300 first. So I'm going to divide both sides by 1,300. Whoa, that's weird. And on the left there, I'm going to get 2 equals 1 plus 0.03 over 4 to the 4t. Okay, now let's do in parentheses here. In our calculators, do 0.03 divided by 4 and add 1 to that. You get 1.075? 0075, I mean? 1.0. Okay, so what I want is an exponent. Would you guys agree there? I want to find my t, which is in my exponent. So what do I need to do now? The whole idea of this lesson is that if I have a variable that's an exponent, I need to log. Right? If I go back up to example 1 on my front of my page, it was 5 to what power equals 3? Well, I had to log both sides. And this is where kind of people start to mess up a little bit, is because it is new. It's a new idea. We've done a lot of other things. We've divided on both sides. We've square rooted both sides. Well, now I need to log. So to get rid of this, I need to log 1.0075. Log 1.0075. So those are going to cancel, and on the right I'm going to be left with 4t. Now, how do I evaluate this? How do I do that? Log base 1.0075 of 2. Yeah, change of base formula. So in our calculator, take the log 2, enter, divided by log 1.0075, 92 point what? On the hundredths for me. 77? Now I need to do what? Divide both sides by 4. We get to like 20 something? 23.19 years. Okay, so if I stick $1,300 in a bank account with a 3% interest rate that compounds quarterly, I'll need to let my money sit there for 23.19 years for that thing to double. Questions there? Okay. On our homework assignment, there's going to be a few problems like this where now I've got to do this again, but now, let's say I'm compounding yearly, or excuse me, maybe compounding monthly, compounding different compound rates, we're going to have to do this multiple times.